If you're trying to build with OpenClaw right now and you don't fully understand how it works, you're setting yourself up to fail. Because OpenClaw isn't just a tool, it's a system. And once you see how it fits together, everything changes. So in this video, I'll break down 22 OpenClaw concepts in plain English, from the big idea all the way down to how memory, tools, and agents actually work behind the scenes. By the end, you won't just know what OpenClaw is, you'll understand how to use it correctly. So let's get started. To understand this new kind of digital employee, let's start with one idea: talk versus do. Most AI agents give you answers, but they stop right there. They help you think, not execute, which means you're still responsible for taking action. So OpenClaw flips that. It doesn't just respond, it's able to carry out tasks. This is where the shift comes from interacting with a tool to assigning work to a system. And because it runs on its own computer, it can actually take action, connecting the tools, managing workflows, and getting things done. Now this is where things shift, because OpenClaw changes how you interact with AI. Instead of asking questions, you now assign outcomes. You're no longer saying, how should I handle this? You're saying, handle this for me. That shift comes from the Agentic loop, the system that separates agents from chatbots. A typical AI chatbot gives one response and stops. OpenClaw runs in a continuous loop. It decides what to do, takes action, checks the result, and keeps going until the task is complete. And every other concept that we're going to cover in this video, such as memory, tools, skills, exists to support this loop. This is the engine behind everything. At this point, you might be wondering, how is it doing all of this? And the answer is simpler than you think. OpenClaw runs on its own computer, not inside of a chat window, but as a system with access to a real machine. That means instead of you doing all the work, there's a second computer running alongside you with an AI operating inside of it, clicking, typing, opening apps, and interacting with the computer directly. And that's what changes everything. It's no longer just generating text. It's taking real action inside of an environment, executing tasks instead of just describing them. Now that you understand that it runs on its own computer, the next question is, how does it get things done? Because this is where OpenClaw really separates itself from most other AI tools. OpenClaw works differently. It operates through what's known as the Agentic loop. You give it a task, it figures out the steps required to complete it, and it begins by deciding what action to take first. Then it acts, opening a file, using a tool, or accessing an app. After that, it checks the outcome and asks, did that work? If the result isn't right, it adjusts. It chooses a new action and tries again, and continues that cycle until the task is actually finished. You don't need to step in or guide it at any stage. The system keeps progressing on its own until it reaches a complete result. That loop is what transforms it from something that simply responds into something that can actually carry out work for you. To make this idea stick, let's imagine asking OpenClaw to fix a bug in your code. Instead of you working through it step by step, it's going to handle the entire process itself. It will read the code, identify any issue, make a change, then rerun it and check the result. And if it fails, it adjusts it and tries once again. It keeps iterating, refining, testing, and retrying until the code works, all from a single instruction. What you're getting isn't just one result, but a full sequence of actions happening automatically in the background. That's the Agentic loop in action. Now that you've seen how OpenClaw execute tasks step by step, the next question is, what's coordinating all of it? That's where the gateway comes in. Think of it as the control center of the system, an always-on engine running behind the scenes that handles every request and action. Every message passes through it first, where it loads context, selects the right agent, and routes the task. And it doesn't just hand things off, it stays involved, coordinating each step as the task progresses. So this isn't just a random automation, it's a structured system with a central layer managing context, decisions, and execution in real time. Now that we've covered the gateway, the next question is, how are you going to interact with it? That's where channels come in. Channels are simply the interfaces you use to communicate with your agent. So apps like WhatsApp, Telegram, Slack, or even Discord. You send a message just like you normally would, and behind the scenes, it's routed through the gateway, processed by your agent, and executed as a series of actions. Once the task is complete, the result comes back through the same channel. So while it feels like a simple conversation, there's an entire system working in the background, one brain with multiple entry points. You might be wondering if multiple apps means everything is split across different systems, but it's not. Everything connects back to one unified system. Every input, message, emails, files, tasks flows into the same central hub, so your context window stays consistent everywhere. What you say in one place carries over to another because it's all connected. You're not juggling separate tools, you're working in a single system that understands everything that you're doing. And even if the underlying AI model changes, the context stays intact. Now, this is where things get really interesting. Up until now, we've been talking about a single assistant, but OpenClaw lets you create multiple agents, each with its own role, tools, and focus. Instead of one system trying to do everything, you break work into clear responsibilities, with each agent handling a specific type of task. They all run within the same system but operate independently, staying focused and effective. So rather than relying on a single tool, you're managing a coordinated system of specialized AI workers. Not only can you create multiple agents, but they can also delegate work by spinning up sub-agents. Instead of handling everything step by step, an agent can break a task into smaller parts, assign each one to a specialized sub-agent, and have them run in parallel. While those tasks are being executed, the main agent stays active, and once everything is done, it pulls the results together into a final output. So instead of just automating tasks, you're coordinating a system that can divide, execute, and combine work on its own. At this point, it can feel like a lot. Multiple agents, sub-agents, memory, but the system is actually quite simple. Everything in OpenClaw lives in its own folder. Each agent is just its own workspace containing instructions, memory, and files. When you create multiple agents, you're simply creating more folders, each with its own role, and unlike traditional AI systems, nothing is hidden. Everything is stored as plain text that you can open, read, and edit. So instead of thinking of OpenClaw as something complex, it really is just a structured set of folders that define how your AI system operates. Now, inside that workspace we just covered, there are a few key files that define how your agent behaves. One of the most important is called Soul.md. This file is essentially the agent's personality. If you think of your agents as digital employees, this is what shapes how they communicate and present themselves. It defines tone, style, and how responses are structured. For example, you might want one agent to sound very professional, clear, concise, and formal, just like a corporate assistant. Whereas another might be more creative, conversational, or even slightly blunt, depending on the role that you've assigned it. And all of that is controlled here. It influences how detailed the responses are, how they're phrased, and how the agent interacts with your day-to-day. But what makes this especially powerful is that it doesn't have to stay static. You don't need to perfectly define it up front. As you work with your agent over time, it can refine these files on its own, adjusting its tone and style based on your preferences. So instead of a generic AI voice, you end up with something that feels consistent, tailored, and aligned with how you actually like things done. If Soul.md defines who your agent is, then Agent.md defines how it operates. This is one of the most important files in the entire system. You can think of it as the agent's operating manual, the set of rules and instructions it follows every time it takes an action. So this is where you establish boundaries and expectations. For example, you might like to include rules like always check my calendar before scheduling anything, never send a message without my approval, or never publish anything without my sign-off. These rules act as guardrails, and they ensure that your agent doesn't just act, but acts correctly and consistently, and that's what makes it reliable. But this isn't just a static set of instructions. You can also build in a feedback loop, where at the end of each session, your agent reflects on what it did, what worked, and what didn't, and then suggests improvements to its own rules. Over time, that means it doesn't just follow instructions, it refines them. So instead of manually updating everything yourself, the system gradually aligns itself with how you want things done. If Agent.md defines how your agent behaves, then User.md defines who it's working for. This is where your agent learns about you. It stores your preferences, things like your name, your time zone, the projects you're working on, and how you like to communicate. This is what allows it to personalize its responses. So instead of treating every interaction like it's brand new, the agent builds a consistent understanding of you over time. So when you ask it to do something, it already has the context. For example, you might prefer direct, short responses, or you could be managing multiple projects across different time zones, and that information lives here and shapes how the agent responds. A simple but powerful example is voice to text. If you tell the agent that you often dictate messages on your phone, it will expect occasional typos or unclear phrasing and interpret what you meant instead of getting confused. So when you send a quick message like schedule a meeting, it already understands your availabilities, your preferences, and how you typically handle those requests. And this improves over time because as you continue working with your agent, it learns about how you communicate, what you prioritize, and how you like task handles, which means you don't have to keep repeating yourself. You're working with a system that adapts to you. Up until this point, we've covered personality, rules, and user context. Everything that guides how your agents think and behave. But the thing that actually allows it to do work is access to tools, and that's what Tools.md is for. This file acts like a practical reference guide for how those tools should be used. And a simple way to think about it is like notes an employee keeps beside their desk. Quick instructions that help them use systems correctly and consistently. Because having access to a tool isn't enough, the agent needs to know how to use it properly. For example, when it should open a browser and how to navigate a specific website, what the correct way to draft and format an email for your business is, or if you're using a particular app, how it should interact with it in the right way. Those details live here. You can also store known fixes, so if the agent encounters a specific issue and has solved it before, the solution can be written into Tools.md and reused in the future, which means it doesn't have to relearn the same thing over and over again. Instead, it builds up a working knowledge base and becomes more reliable over time. This is where things start to feel powerful, because most AI tools forget everything. You close the chat and start from scratch again. But OpenClaw doesn't work like that. It uses a persistent memory system with two layers. The first is short-term memory, where the agent logs actions, decisions, and tasks into a simple text file organized by date. Like a daily work journal, so it always has a clear record of what's been happening. As the information builds, the agent identifies what matters and promotes it into long-term memory, stored in a file called memory.md. This then becomes its knowledge base and includes your preferences, key decisions, and reoccurring patterns, so when you return, it already has that context. Up until now, everything starts with you. You send a message, give a task, and the agent responds. The heartbeat changes that by letting the agent act proactively without being prompted. At a set interval, by default every 30 minutes, it wakes up and checks if anything needs attention by reading a file called heartbeat.md, which contains a list of things to monitor. From there, it checks for events that may require action, like upcoming meetings, important emails, or whether sub-agents have completed their tasks, without you having to ask in real time. So instead of waiting for instructions, it continuously observes and steps in when it's needed. When you first set it up, Heartbeat.md will be empty, and it's important to keep it focused because a large checklist can increase token usage and cost. Used well though, this makes the system feel less like a tool and more like an assistant actively looking out for you. But what if you want something to happen at a specific time, not just when it's needed? That's where cron jobs come in. A cron job is a scheduled task you tell your agent to perform at a specific time and it runs automatically. For example, you might schedule a data transfer every morning at 8 AM, a daily briefing at 9, or a backup every Friday at 11:45 PM. Once set, it runs in the background with no prompts required. This is ideal for a repetitive, time-based task. So now your agent isn't just reacting or monitoring, it's following a defined schedule and executing tasks when it's supposed to. Now, here's something most people don't realize about AI. It doesn't have unlimited memory. There's a strict limit on how much information it can hold at once, and this is called the context window. You can think of it like a container. Every message, every file, and every piece of information gets added into that container as tokens, roughly equivalent to words. Some models have very large context windows, up to around 1 million tokens, which is comparable to the length of an entire book. But even with that capacity, it eventually fills up, and there's a reason for that. Your agent is constantly reloading its instructions, rules, and context every time it runs. So over time, more and more information gets packed into that space. Without a system in place, older information would simply fall out, and the agent would lose important context. But OpenClaw handles this differently. Instead of letting information disappear, it compresses it. Older conversation and notes are summarized into smaller, more efficient versions while preserving what actually matters. So instead of storing a full word-for-word history of a long conversation, it keeps the key takeaways. Now think of AI models like switching between different brains. You're not just stuck with one, and each one is better at different things. For quick tasks like chatting, brainstorming ideas, or writing emails, models like GPT-4 or 5 are a great choice because they're fast, easy to use, and strong across a wide range of everyday tasks. For coding, debugging, code review, and more structured problem solving, models like Claude are often a better fit, and they also work well for analyzing long documents and writing detailed content step by step. If your work involves multiple formats like text, audio, or images, models like Gemini are designed for that kind of multimodal work. And if you need privacy or full control, like working with sensitive data, open source models such as Llama or Mistral can run on your own machine, keeping everything local. So instead of asking which model is the best, the better question is which model is best for the task, because the real advantage comes from knowing when to use each one. And once you start thinking this way, everything changes. You stop relying on a single tool and start building a system. You might use one model to generate ideas, another one to refine and structure them, and another one to execute or automate parts of the workflow. That's when AI stops being something you can just interact with and starts becoming something that actually works alongside you, almost like a team where each model plays a specific role depending on what you need. Now with all of this, multiple agents, continuous loops, background processing, we need to address the obvious question. What does it actually cost to run this? Because if you're not careful, an AI system running continuously can become very expensive. The key thing to understand is that your setup determines your cost. When you connect OpenClaw to an AI model, there are typically two approaches: using an API key or using OAuth. Let's start with the APIs. With an API, you're charged based on usage. Every time your agent reads or writes text, it consumes tokens, and you pay for those tokens. Since your agent is constantly running in loops, checking context, and performing actions, these tokens can add up quite quickly. There's no fixed limit, so if your usage increases, your cost increases with it. On the other hand, you have OAuth. This works more like a standard subscription. So instead of paying per token, you connect your agent to an existing plan like a ChatGPT Plus subscription, and you pay a fixed monthly amount. So whether your agent completes 10 tasks or 10,000, your cost stays the same. That predictability makes a big difference, especially when your system is running in the background all day. So here's a simple guideline. If you're a developer testing at scale or building advanced workflows, APIs give you the flexibility, but if you're just getting started or want predictable cost, a subscription-based setup is usually the better choice because it lets you run your agent continuously without worrying about unexpected bills. Now let's finally talk about permissions, because this is what keeps everything under control. At the core of this is a configuration file called openclaw.json, and this is where you define what your agent is allowed to access. For example, you might enable browser access so your agent can search the web, gather information, and run research tasks. But you might disable file access so it can't read, modify, or delete anything on your system. That choice matters because the more access you give an agent, the more powerful it becomes, but also the more risk you introduce. If it has access to your files, it can organize and manage them, but it could also overwrite or remove something unintentionally. A good way to think about permissions is like giving out keys. You don't hand over every key you have, you only give access to what's necessary. And you can combine this with everything we've already covered. For example, you could set up a scheduled task to run regular checks on your system, making sure permissions stay exactly how you want them. The best approach is to start minimal, only enable what your agent needs and expand from there as you get more comfortable. Because in systems like this, control doesn't come from what the agent can do, it comes from what you allow it to do. And that's everything. You now understand the key core concepts behind OpenClaw, from how the agentic loop works to memories, tools, and how it actually runs as a system. At this point, you're not just looking at AI as something that responds. You now understand how to turn it into something that actually works for you. Now the next step is setting it up properly. If you want to get OpenClaw running on your own VPS with a simple one-click install so that it can operate 24/7 in the background, click on the video on your screen and I'll walk you through the entire setup step by step. I'll see you in the next one.